Okay. Before I proceed with my lecture, by the way I'm conducting this lecture is will be more on two ways communication, because I want you guys to engage in the discussion so that I can ensure that you guys really can get the understanding of the subject. Right. So before we go, okay, I just want you guys to conclude. What you guys have learned so far, and then what do you think about SoC? What is SoC? And then what are the things that you guys, maybe you guys still confused, you don't understand, right? Or whatever, right? So your opinion on this subject so far, right? So that at least I can get a good idea where are you at right now, so that I can level my presentation accordingly. All right. So can you guys just speak up and tell me what you guys have understood so far about this subject? What you guys have learned from PM Dr. Asram? Right. Who wants to go first? I want to hear from all, of course. Just four of you. Okay. Nawari. Okay. Chawali, you want to go first?
Yes, Ted.
Uh,
Okay, the importance of SoC is because one of the most important in economy, and it will continue expand fast. So the SoC is consists of processor, on-chip memory, system bus, isolation function unit, analog or mixed signal, and MEMS. So in SoC they have many methods. We have micro P, gate array, FPGA, cell-based design, and full custom. But in SoC, mostly the most focus is cell-based.
okay.
Okay, cell-based design. So cell-based design is include small-scale integration, memories, system-level module, and mixed signal.
Okay.
So basically, the cell-based design is use a standard cell library as the basic building block at a chip. Then the interconnection are routed within the block.
Okay.
So in SoC also, I've learned about IP. We have hard IP, soft IP, and firm IP.
Okay.
So for hard IP is layout. So it consists of power, speed, but for soft IP is RTL, or we can say coding, Verilog.
Okay.
So firm IP is between them.
Okay.
Okay. And then I learned about the interconnection between the block. We have
Okay.
on chip and off chip interconnection.
Uh-huh.
So and then but okay, I've learned about floor planning, routing, pick and place, the pick and place first, and then floor planning and routing.
Okay.
Um, and then processing, I think.
Okay. All right. Okay, that's good. You can see a lot of things, right?
Yes.
Yeah, a lot of things, but don't worry. You guys are learning surface, because the most important thing, I think, is the what do you call it? The you see the direction, in this subject, will give you understanding, on the whole process of the SoC design. Okay, Charlie, what do you think? The things that maybe you are not clear about the SoC.
At the beginning, uh, I'm still clear because my undergrad is integrated electronic.
Okay.
Okay, study about VLSI, so IC design, but
Uh-huh.
not into the fabrication process.
Uh-huh.
So, but then come in processor design and memory, start blur, but still can catch up.
Uh-huh.
Uh, I think that's all.
All right. Okay. Thank you, Cha. I think that's a very good,
Welcome, doctor.
yeah, very good summary of what you have learned. Anybody else want to try? What about Yip? You seems to like more on analog. How do you perceive this all this digital thing? Yip?
Yes, not like
Yeah.
I go to analog, just that more to fabrication part like MEMS and
Yeah.
then doing the chip fabrication thing. So
Okay.
I know about the wafer and then about the fabrication process like lithography, everything.
Okay. All right. So how do you perceive this subject?
This subject got something like coding also, but that's not my. I'm not very good with coding, so I struggle with the coding things.
Okay. Coding is just a part of it, right? That's just a tool, I think.
Yes,
Okay.
yeah.
All right. So so far, what do you understand about SoC? Yip?
SoC is to design a system on the chip. So it like putting the memory blocks, everything, and then
Uh-huh.
for the marketing things, it do
Okay.
for the second things like for the IC chips and SoC got a lot of things to learn and there's a lot of things can be do inside the
Yeah.
system.
Yeah.
Too many things lah.
That's right. Because yeah, that's why you have to. Yeah, I know. That's why when I see the syllabus, I know this is a broad thing. You know, this is a combination of computer architecture subject, combination of
Yeah,
some part of fabrication subject. So they're
because the
two.
all the design for the different functionality. You can
Yeah.
say for FPGA, you can say for other things, a lot of the function, and then the system to do for the function is very what
Yeah.
every design, you will
Yeah.
not say that I just design this thing accordingly, and then not for the function
Yeah.
cannot lah. Is
That's right.
sometimes you need to change a bit things just for the
Yeah.
function.
That's right. Yeah, so I think that's the thing that we have to identify lah in SOC. So that's why if you guys see in the current market right now, SOC is growing very fast. Do you guys know about the latest processor that being used in MacBook?
M1.
And
So yeah, Cha just said it. Is M1 processor. Right. So, if you look at the news, the M1 processor, you can watch a video. There's a comparison being made, why Apple decided to stop the MacBook from using Intel processor and come out with their own processor M1. So there's a comparison being done on YouTube. You guys can Google it. They compare, this very high-end Mac desktop, and then they compare it with an iPhone. iPhone is just using, as a mobile SoC, right? Of course, their own mobile SoC, A3, A4 processor. So they compare it. He do some video processing with high end, the expensive Mac desktop with an iPhone. And then who completed which one completed the processing first? Is the iPhone, right? So okay, that's why why is that happening? Because Intel is designing what do you call it? General processor. processor that can process a lot of things, right? But Apple already customized their SoC, the chip for the mobile phone, to focus on image, because if why people buy iPhone, because of the picture image, because of the video quality, right? So all those selling point for Apple. So that's why right now they are, and then even the MacBook, right? Why people buy MacBook, Mac desktop, because people that involved in multimedia, graphics. That's why they are using Apple. So that's why right now, if you see the trend is going there, and that's why right now Intel is also evolving, right? So they have to shift, not shift, or they have to invest more on this segment, so that they are not going to be left out in the market, right? So that they still remain valid in the market, right? So that is one of the things that you guys need to observe, right? All right. So let's hear from Q. What have you understand so far, Q, about this subject?
So far, about more about the theoretical part, the,
Yeah.
the placement, the floor planning, netlist, routing, timing analysis, and so on.
All right. So, but I think most of the stuff you have covered in your during your undergrad, Q.
Uh, so far, now my my undergraduate never know about the SoC,
Sorry, your undergrad, what?
never learn about the
Uh,
system on chip.
but did you learn about computer architecture, Q?
Yeah, only a little bit.
Okay. All right. Okay. All right. Thanks, Q. What about Omar? Omar?
System, sorry, system on chip that architecture.
Your voice is not clear, man.
Okay, hear me.
Uh, okay. I think that's okay. Better.
Okay, system on a chip architecture is in a assembly of a processing and memory and to application domain.
Uh-huh.
A simple example is in PlayStation and iPhone. All this is there is a system on a chip.
Mm-hmm.
Okay, um, and system in chip aside and hardware implement implementation. Okay, so
Okay.
I understand, but I'm actually this subject is new for me because I'm
Yeah, I know.
communication engineer.
Your background is communication.
Yeah, I'm communication engineer.
All
Yeah.
right. All right.
So this subject new for me.
Okay, understood. But it's okay, you don't worry, because just take this subject is more on theoretical lah, like Q said lah.
Yeah.
And there are a lot of things that you have learned so far, a lot of theories, because like yeah, I think from your summary, like Yip Cha summary, that that this subject is a very broad subject, right? Talking about SoC, there are many things about SoC, right?
Yeah.
So, for an example, like you said, Omar, right? PS4, right? PS4 is using SoC, right? And then if you see in the server, right now in the server market, Google, Amazon,
Yeah.
right? They are using SoC.
Amazon or also CS.
Yeah, but and then there's all the high end. But if you go to the low end, look into your activity tracker, Mi Band, all those Huawei band,
Yeah. And
also
Samsung
using SoC,
using.
right?
Yeah.
Okay. If you go lower end, lower end, you go into, the small things like remote control car or whatsoever, is also using
As a system on
SoC.
chip. Yeah,
Okay.
SoC.
That's why you can see they're a very broad design. Even in the communication, there are a lot of SoC. right?
Yeah, yeah.
SoC in the router, even
Router.
when you said about the phone, right? At the switch, and the communication switching
And
place.
antenna.
Yeah, so
Yeah,
you can see, it's everywhere. Yeah,
yeah.
that's
It's
why. Yeah, that's why this subject is become, I think, important for you
yeah,
guys.
important.
Yeah, at least you know what is SoC and what are the process involved in designing the SoC. Yeah,
Yeah.
but later we gotta see. Is it really that you guys need to go through all these things later? Let's say if you want to go and work in the company, right? Are you guys really going to apply all this knowledge? It depends, right? Because right now there are a lot of advanced company offering their SoC. Later I'm gonna give you some tasks, then you guys gonna go and try to discover by yourself lah. What are the SoC that we have in the market? All right, thank you, Omar.
Okay, which country?
All right, so okay. By the way, guys, so I'm gonna start, discussing about our subject for today's or this week, and then in the meantime, I'm gonna ask you guys questions. So please, pay attention. During Dr. Asral class, did he ask you guys to turn on the camera?
No, rather.
Okay, all right, okay. So you guys prefer to turn on your camera or no?
Normally no.
Okay, all right. Okay, that's fine. Okay, that's okay for me. Just if you guys want to, you feel boring if you cannot see my face, right? But if you want to see my face, just let me know. I can just switch on my video. You can watch my my face. All right. So okay, today we're going to discuss about hardware, software, co-design. All right. Okay, what is hardware, software, co-design? Right, so co-design is an okay. By the way, I'm gonna give you guys the the all those PDF things, but I'm not sure. For me, I don't like to see to read from PDF, so I did some work for you guys. So I extract it and I turn it into lecture notes. I'm not sure. Maybe I think it's easier for you guys to understand by reading lecture note. Okay. All right, so co-design is an important step during rapid system prototyping. What do you guys understand by rapid system prototyping? Anybody want to guess? Q, want to guess what is rapid system prototyping?
No idea, doctor.
No idea. What about Yip? Yip, have idea? Yip?
It's a very fast processing prototype is how to say it. Yeah, I forgot.
Yeah, that's right, lah. Yip. It's a fast design process, lah. Right? Okay. Sorry, I got running nose a bit. Okay, so rapid. What is rapid? Okay, rapid means fast. System prototyping means that from design, right? So let's say there's a customer here, right? So here customer, they come to any company. Let's say they come to company A, and then they say, okay, company A, I am from Samsung got their own design, right? Okay, let's say like this is example, right? So it's a TV brand. Let's say Hisense, right? So Hisense brand, or let's say LG lah, LG. Okay, so this is a customer is from LG. Go to SoC company, SoC design company, say that, okay, please, I need a very fast SoC design ready to be in the market within 3 months, because I want to compete. If you look into the TV business, what else, smartphone business, all of these business, they have to be fast to bring their product in the market. Why? If they are late, then they're gonna lose the market, right? So like Apple, Samsung, they are competing. Every time they try to produce the latest design, and then to be the first one in the market. Even the car, right? That's why car right now, even they got their own SoC in car. You look at Mazda, BM, Toyota, all of them are trying to compete to be first in the market. So that's why there's a term of rapid prototyping, right? Because they are all need to use SoC. So when they want to be fast, they have to have a very fast process. If you guys go through the normal process, like for example, fabrication process, you learn about fabrication, to get one chip ready during using the normal fabrication process. How long, Yip, the process is?
Well, quite long. When I do the just a normal MOS, PMOS, I mean the CMOS wafer lah.
Uh-huh.
We do the lab session every week, 2 hours. We take some like few weeks already, 4 weeks.
Uh-huh.
cause a lot of waiting time, like the
Yeah.
after lithography, masking,
Yes.
every
Yes.
interval got a lot of waiting time need to wait.
Yeah. That's right. So that's why that mean fabrication process. That's just a lab work. But if you go and design a chip, so it's gonna take you 1 year and a half, 2 years, all those lithography, masking process. Then you got the chip. Then you test it, something wrong, you go back to the design process. All this kind of circle is really wasting time. So that's why they come out with rapid system prototyping. So because from the customer spec demand what they want, so let's say they say for TV, so let's say they specify what are the input and the outputs they need, what are the specification, the timing requirement that need to be met. So when they give it to the SoC design, right? So SoC design company, and then they need to produce a plan. So let's say, for example, 3 months for the product to be ready in the market, right? So this is product ready in the market. Means that already tested and ready to run. Right. So that is when we say this rapid system prototyping. So it's starting from system level spec, right? So co-design produce a heterogeneous architecture composed of software, hardware, and communication modules. Okay, here you can see they divide, right? So they divide three components in this co-design, right? The first one is software, second is hardware, and of course the third one is the communication modules. So how you want to communicate between these thing? Okay, let's go into wait. Okay, let's discuss this one first. Co-design is generally composed into four refinement steps: system levels, spec, system level partitioning, communication synthesis, and architecture generation. Right. So wait, let me get this slide. Okay, all right. This one I'm giving you guys overview, so that you guys, I think it's better to give you guys an overview, so that at least you can grab the knowledge what we try to get in this subject, or sorry, on this chapter. Right. So the first one, okay, we following our previous example, right? So the customer, let's say from LG came and then gives you guys the spec. So spec, right? So spec, so they're going to define. Spec is a high level definition, high level description of the system. Okay, let's say this is just example, right? So they want output, right? So they want, what's the output that they want? Okay, so output that they want, okay, might be the first one is 4K, right? This is a 4K resolution. All right, so this is for the video. Right, so what about the sound? So the sound, they want the 5D, right? So this is the audio, Right, so what else they want? They want the TV to be connected to the can be connected to internet, right? So they need to have Wi-Fi connection capability. All right, so as you can see, all these things are will relate finally to software and also hardware. But this one mainly hardware. Okay, then they say okay, and then we want you guys to provide an OS. If you guys look into smart TV, okay, let's say this one for smart TV lah, right? For smart TV, right? So for smart TV, they also want it to be to have this Netflix ready, right? So they want to have Netflix. So you just need to log into your account and then you can watch your Netflix video. And then you also need to have this YouTube, right? So and any other apps that they want. So this is the output. And then how you going to control, right? So you need to have the remote, whatsoever, right? So these are all the specs that they want, right? So based on all these specs, right? Then you have to determine, okay, what's the hardware, right, that we need, right? Okay, then what's the software to support all this capability, and then how we connect, right? All these modules. Okay, so as you guys know, to design SoC, they have the IP, right? So they have the IP design. So maybe a lot of IP. Okay, so when it comes to the design, so you know that, okay, you need to have the 4K video IP, right? So this is video IP. And then you need to integrate it with 5D audio, right? So audio IP. Then you need to have Wi-Fi, so you need to have the Wi-Fi IP. But who going to manage all those process? So of course, you need to have your processor, right? Maybe you use ARM processor or whatsoever inside the IP. Okay, so then you have decide. Okay, these are all your hardware, right? So these are all your hardware goes here. So, okay, so it's a bit messy, right? But this is how we draw it. So for the software, you can choose. For example, if you guys are using let's say ARM processor, okay, what are the software that compatible with ARM processor, right? And then for the image, right, so how you going to process the image? So all those things are related to the processor. The hardware are capable of processing, but who going to manage it? It's the software part. Then the connection between the modules, right? So those are the connection. All right, guys. So far, so good. Okay, dah. Is it okay? My explanation here, example that I show.
Yeah, okay, betul.
Okay.
Okay.
All right. Q. Okay, Q.
Okay, doctor.
Okay. All right. So if you guys have any question, just stop me. Right. Okay. So that is co-design. The meaning of co-design, So you guys cannot do this one. One at a time. For example, you do the hardware first, right? So you have to do it, concurrently at the same time. By the time you determine what hardware that you are using, the connection, you also need to figure out how you're going to control it by using software. And at the same time, you have to think about how you guys to connect all those modules, right? So that's what they call as this co-design, right? So that's why they say co-design produce a heterogeneous architecture composed of software, hardware, and communication module. Heterogeneous is the antonym for heterogeneous is homogeneous. Homogeneous is only one. Hetero means that there's a multiple things inside one process, right? So the multiple process is the software, hardware, and also communication modules. Okay, then the co-design is generally decomposed into 4 refinement steps. System level spec. All right, so this is the system level spec. Right, and then the system level partitioning. So how you divide it, the system level partitioning, you divide it. So which part is the processor, which part is the video, right? What is involved in the video, what is involved in the processor, right? So you partition and you try to solve one by one each partition. And then communication, so when you have all the modules, so you have to think how you want to communicate with all the modules, the connection. So what are the best method of connecting all those main modules? And then architecture generation, so finally the architecture lah. So that's where we talk about how you want to improve the design in the physical layout and everything lah. Right, so however, the co-design process depend on, okay, so yeah, there, because like we said, there is a broad thing and there are many ways of way that we can do it. So we can use there are a lot of language that can be used, and there are a lot of architecture, right? Means architecture, we are referring to the processor. For example, we can use mono processor, means that only one processor, and we can use multi processor, means that we're gonna have a multi-core processor, a lot of processor. So how do you decide on that thing? I think they go slide. Uh, all right, so the mono and also the multi-processor, how you going to decide it? So it's really based on your application. For an example, okay, this is let's say mono processor. Right, so this is just one core, one core processor, and this is your processor. And then you have a multi-core, right? So it's a multi-core processor. You have a multi-core, right? So let's say you just have 2 cores, right? Okay, so it's really depend, right? So how you make a decision. So it's depend on your application. For an example, you are designing a very low level application. For an example, you just need to design SoC for washing machine, right? So if you guys look at the washing machine spec, right? So you just need to determine, there's a sensor and there's a timing. There's not so much processing that need to be done. Just the user gonna set gonna put in the load, and then they're going to sense how much load is in the washing machine. Then you guys the washing machine going to determine the time, right? Then start the process, control the motor, control the water inlet, water outlet, everything, right? So not so much processing, right? So maybe you can go and choose for single core. But when it evolves, right, for example, a lot of processing, okay, let's say TV, right? So you need to process video, right? So video, of course, you need to use this, what do you call it, graphic processor. So it's a GPU. And then you need to process audio, right? And then there are many things. So maybe then you need to have the multi-core, right? So that's why the target architecture is also will be affecting this co-design process. Right, so it denotes a joint development hardware software components in order to obtain a complete design. So co-design is not exactly the latest novelty. This is not something new. This is something very old. So that's why later we're gonna see, this is the foundation, the theory that we're gonna learn. But in today's current market, how does the SoC design is gonna be, right? So we'll see later. Like to join spec, design, and synthesize of mixed hardware software systems in recent issue. And then co-design is also important step in rapid system prototyping. So it's an important step. Let's say you want to achieve this rapid system prototyping. Of course, you need to have a very good co-design strategy. Yeah? So figure below shows a typical rapid system prototype RSP design flow. Right. So this is a standard flow. Right. So you guys have to be familiar with the flow because this is our core discussion, right? So later you guys, if you want to test your knowledge, we're going to test the knowledge based on your understanding of the flow lah. Right. So again, this is the system spec, right? So like what we did before. So this one, the system spec, what you need, right? So this is very high level spec, and then comes into executable spec. So how you want to execute all those spec, then you determine all these things, right? Then go into the co-design, right? So this is you start to do the co-design. So you need to have the hardware, software, then of course you need to have the virtual prototype. Virtual prototype means that it's more onto the simulation part because that's why you call it as virtual. Then finally it goes into the hardware prototype. So where you can really test the timing, the functionality and a lot of things. Just want to give you ideas for an example. Like Intel, because I have experience with Intel, right? So let's take Intel Kulim for an example. So they are design a lot of things. So let's say they design the processor, right? Okay, when they design the processor, so there are a lot of steps. Most of the initial design steps, the fabrication is being done in US. Right? So they start because it's a general processor and they have a legacy design, So they just do some improvement and they come up with the new generation of processor, and then they fabricate it. So after they fabricate, then they send to Malaysia, right? So they send to Malaysia, do the cutting and then putting on the pin, the what do you call it? Yeah, the contact point. Okay, then they do the validation, right? So when they do the validation, when they're going to test the functionality, right? So they're going to test, the video functionality, the BIOS functionality, because one of my master students previously, he attached with Intel and he involved in the BIOS validation. So he's validating the BIOS setting for their new processor, right? So they see whether the design works or not. If there's a problem, they're going to feedback to the engineer, to solve it by using the software. If they cannot solve by solving it by software solution, of course they're going to go into the hardware solution. But it's a long process here. But here we are talking about rapid system prototyping. So it has to be fast. It cannot take, I think if we talk about rapid, it shouldn't be more than 1 year process. Okay guys, so far do you guys have any question?
No yet, Doctor.
Yeah, all right. Yeah. Okay, wait, guys, let's take a break for 5 minutes. So now it's 11:55. Let's take around 5 minute breaks. So I'm gonna go to toilet. I think I just want to fill up my cup here with my drinks. Right. So we'll start around 12. Okay. Is it okay, guys?
Okay, Doctor.
All right. Okay, guys. Let's continue. All right. So, I guess all here. Shah, Q, Yip,
Yes, sir.
Umar. You guys there?
Yes,
I'm here.
perfect.
Okay, Q there. Yip.
Yes, doctor.
Okay, all right. Just want to make sure that I'm not talking alone. All right. Thank you guys for responding. Okay, let's continue. All right. So, co-design. All right. So this is uh, rapid system prototype. Right, then we can see here, so the co-design process may be iterative. Iterative means that, it's not like one way. So for example here, right, so from system spec to executable spec, so normally this can be one way, but it can be two ways. For an example, right, so there's a spec that being asked by the customer. For example, let's go back into our example here, right? So let's say they want, for an example, okay, nowadays I think they have the 8K, right? So 8K video, but then you go and check at your library inventory, you don't have the IP for 8K. Maybe you haven't buy it, or your company cannot afford it. So maybe you go and tell them, okay, we cannot give you, 8K, but we can have, like 4K ultra, for example, right? So this is just example. All right. So and then you go and talk to the customer, and then the customer say, okay, right. So we agree to go with 4K ultra instead of 8K. All right. So then you go back, right? Change the system spec, and then go back to execute spec. Then go into co-design. Then again, in the co-design, there's something happen. Maybe there's the hardware some problem or whatever, and then you go and change back a bit, right? So go into the hardware and software design, and then determine the things, and then go into prototype. Then when you go put into prototype, then you find out, oh, there's a bit delay, right, in the video or in the audio. The sound is not that good. Then go back into the co-design process, do some changes, and then go again prototype, and then do the testing, this kind of thing. So that is what they call as iterative. All right. So then the main steps needed in order to transform a system level spec into a mixed hardware or software. One are system partitioning, communication synthesis, architecture generation. Right. So these are the three main steps lah: system partitioning, communication synthesis, and architecture generation. The output architecture generation is a heterogeneous architecture. Output architecture generation is heterogeneous architecture composed of hardware and software modules. Of course, because the output right here on the architecture generation, it has to cover the hardware and also the software modules. Because you have to know that all different hardware need to have different software. I give you guys example lah. For an example, kan, you have a new device, right? So your device, you buy a new device. Okay, let's say give you an example of let's say you buy something that you need to connect to USB. Example like a drawing pad, right? Okay, all right. So you guys buy a drawing pad that you connect to USB, all right? Wait. Okay, so let's say you buy a drawing pad, you connect to USB. Then you connect it to the USB, but you cannot use it. You just connect it, then you try to use it, it's not working, right? So why is it's not working? Okay, let ask you guys lah. Why do you think it's not working at the first time? Any guess?
I need some time to install the software.
Okay, all right. So more specific, Cha, is a driver, right? You call it driver,
Yes,
right?
sir. Driver.
Yeah. So driver is software lah. right? So the driver, you need a driver, to tell the processor which going to communicate with the module that okay, this is a new device and here is how the new device talk. Right, so let's say this new device talk in Mandarin, right, and then the processors talk in Malay. So when both language is not the same, so there's no communication can be done. Right? It's not, you cannot establish the communication. Then when you install the driver, so the driver is sending a new language to the processor. Now the processor can speak Mandarin too, right? So now the processor can interact with the drawing pad, right? So that is an example of these hardware and software modules. Right? So all of the hardware they need a software modules to function. So this step is decomposed into two tasks: virtual prototyping and also architecture mapping, prototyping. And then virtual, like I said before, is more on the software part, simulation part, make sure that everything functionally correct. Right? Take an example, FPGA lah. FPGA you can do it by software first. You design the hardware, then you design the software, then you simulate it. Just want to see how the output works. If it function as you want or it's not function as you want. So if it's not function as the one that you intended to, then you have to change the design until you get whatever function that you need. Then after you done the simulation part, then you go into the hardware prototyping. Right, so the architecture mapping step produce an architecture that implements or emulates the initial specification, right? So it has to emulate, right, to represent the initial spec, the spec that specified by the customer. Okay, taxonomy of co-design, system level spec, right? The system level spec of a mixed hardware software solution application may follow one of the two schemes. The first one is homogeneous spec. A single language is used for the spec of the overall system, including both hardware and software parts. The second one is heterogeneous modeling. Specific language are used for hardware part and software part. A typical example is mix, C, and also VHDL. Have you guys learned about VHDL or Verilog? Do you guys
Very
know?
long.
You guys learn Verilog. Where
Yes.
where in this class?
Also in degree also.
Oh, okay. In this class, Dr. Asral teach you guys Verilog?
No,
Um,
in digital.
uh,
Digital, you guys learn Verilog. Okay, all right. So that's good. And then I think of course you guys know C. What about Omar? You know about Verilog or VHDL?
Yeah, I was studying last semester in digital electron,
Okay,
but
who
in
who
degree no.
who taught you guys digital?
Yeah, in digital
Who's the
advanced
lecturer?
electron. Dr.
Dr.
Rafika.
Rafika.
Rafika, yeah, Dr. Rafika.
Oh, okay, Dr. Rafika. All right, okay. Okay, all right. So, modeling. All right, okay, guys. Modeling. Okay, show you an example. All right. Okay, so for homogeneous, right? Okay. Okay, this one for homogeneous modeling. So if you guys look into the homogeneous modeling, you guys can refer to the slide. So there's an ideal SLDL, the design language, and then there's spec system design. Then it goes into the hardware and software. So you just follow the normal rapid prototyping flow lah, right? Okay, so if we go and look into SDL, it's a specification description language. You guys can Google it. Even I think I give it the link into in the slide. Just go and can check it. It's just, or you can just Google it and then check it in the Wikipedia. Right. So this is example. So this is a high level spec and more into block way of modeling. Modeling means that you try to model how the system gonna be right? For an example, okay, you already got the spec, right? So okay, let's say this is the spec for video, and then there's a spec for audio. So inside the video block, so there's a process, right? Receiving the video, processing the video, improving whatsoever. So in each process, there's gonna be all those details, right? So this is the specification and description language. So you're just using one language to represent both software and hardware. Right, so if you look here, there's no differentiation between the hardware and software. So everything is just using one common language. Right, so that's how they do it in this homogeneous spec lah. So that's why if you look into the homogeneous spec, so you do the design first using one language until you go into the virtual prototyping, then you use a different language. For example, for hardware and software. Right. Where else for heterogeneous, in the beginning, you are not using this spec design language anymore. So you are using C and also VHDL in the beginning. All right. Okay. Let me. Right. Okay. So based on the spec, right? So we already determined the spec here. So what we need here for our smart TV. Okay, let's say they go for SDL spec design language, right? So okay, so this is the top flow. So what you want here is that you want let's say 4K, right? 4K smart TV. Right, so inside the 4K smart TV, what you want to have is of course the video, right? The video, and then you have the audio, and then many other things. So inside the video, what you need to have, so it's a process, right? So there's a process in here, process 1, right? So this all detailed process, right? Process 2, right? Okay, but in here you don't worry about the, you are not really worrying about the software and hardware, really. So you just want to see the whole process. You have to know what's processing here, what's processing in here, and what's processing in the video, right? And then complete flow of it, right? Software, spec, description, language. Whereas, so this is homogeneous lah. This is homogeneous. Right, so this is a different way. So there's no right or wrong way. You can use both. So it's really depend on which way that you think that is more structured and easy to achieve your objective lah. So later when you go into industry, maybe they're using both approach. It's depend on the design, or it's depend on the the team lead, right? Which approach that they want to use. So it's depend. But if they are using, this hetero, right? Hetero approach, hetero. Okay, in the beginning, they already mentioned, all right, okay, so look into the VHDL, right? So VHDL. Example, oh no, you just learn very long. Options. Eraser. All right, so okay, Verilog, right? Okay, Verilog, and then this is for hardware, and then you use C lah for software. All right, guys. Okay, Verilog. Okay, I just want to re-explain because maybe if some of you still confused. Here you are using programming language to design a circuit. Right, so you are developing a module, hardware module, and then you still need a software, right? So you need a software to run into the module, which is you use C or any other programming lah, but it depends. So in our example, we are using C. So for the hetero process, in the beginning, they already do it block by block, right? So Verilog, okay, video. Okay, find an IP for video. So in Verilog they have the IP ready. Right, so the IP for let's say for video, right? Okay, then okay. So what we need when they decide the video for the IP for video, then they already check what are the software needed, right? So the software needed. So this is hetero approach, right? When they determine each modules that they want to use, they already determine the software. So it depend. How do you think? Right? Maybe you can see that. Okay, why we need to use homogeneous then? That is almost the same process. If you go to hetero, then we skip all these things. But some might say, if you evolve in high complex high level design, very complex design, you might miss a lot of things, if you use hetero. So might as well just use homogeneous. So it's really depend, right? All right, so and then you determine, video audio module, and you determine the module. So this is hardware part, right? So this all on the left is hardware part. Then you have to determine what software that you want to use for the audio. All right. Okay, guys. So far so good. Oh, it's just confusing, you guys. Q, is it okay?
Yes. Yes.
Yip, Omar.
Yeah, okay, Dr.
All right. Yip, okay, Yip.
Okay.
All right. Where are you staying, Yip? You back in hostel or still at your house?
At my house in Penang.
Oh, you are in Penang. Which part? Island or Seberang?
Island.
Which part? Island, Georgetown.
Yeah, near Georgetown, actually in Jelutong lah, to the exact.
Jelutong. One thing I wonder, why you didn't just get a job? You just want to still learning?
I want to improve my opportunity, and if direct study from degree, right, a lot things still fresh, right, so I can still continue it if I after I working, and then suddenly I want to study back for master, maybe something already forgotten.
Alright. Okay, because you are rare species. I know a lot of Chinese students from Penang. They don't want to continue study. They just want to work. Yeah, because a lot of opportunities in Penang, right? Yeah, but
Yeah, cause
yeah,
my friend from Micro E a lot really get job from
yeah,
Intel or Opstar, because that time the company come our school to interview them.
yeah.
Then they ask me also why you never go interview it, and
Uh,
but I also know that cause my dad last time also work in company, right, and he
uh-huh,
say a lot of the Chinese engineering, like they more to taking the MBA
that's right. But it's
MBA
depend lah.
course.
Yeah, it's depend because sometimes they say MBA is useless, but some yeah, right, because it's depend. It's depend, right?
It's
Because
depend lah.
yeah. If you want to go into management level, yeah, maybe MBA can help you, right?
They want to do manager. Then
Yeah.
okay, for me, I'm not into managing other people still. I
Okay.
want to do my own work, so I that's why I want to continue.
Okay, that's why. But as a woman engineer in MNC, you have a very bright opportunity. Yesterday, I just have a session with Intel engineer. They are promoting one of their facilities lah in PG12 Penang lah. So the spokesperson, the in charge person is a lady engineer, and she's a principal engineer. Wow, I think that's really wow me. To be a principal engineer at Intel is not easy lah. You can say, once you are principal engineer, that means you know in and out in a certain expertise. They say you are, signal integrity expert. right? Then you can become the PE. But that means you are going to be a person that people in Intel will refer to if they have any problem regarding that thing, and she's a lady, but I think so. If you want to go that way, you have a bright opportunity, of course. Plus, you need to do a very hard work, lah, kan? Of course,
Yes, of course, the hard work is the most important thing.
yeah, that's
I
right.
also know that Intel is a very stressful place. A lot of people say they
Yeah,
keep on pressure you
that's right.
until
That's
you
right.
really very stressed one.
Yeah, that's right. Because yeah, that's the only way you want to get a good result, right? But yeah, in the end, it's too much stress is not that good. But it's really depend on what you are going for, lah. So if you really want to go for that expertise, that is your dream, then you go ahead and go get it, lah. Right. Okay. Let's go back into our subject. Right. So okay. Then okay. Now you guys can see lah the difference between the homogeneous and also heterogeneous. Right. So like heterogeneous, you see they start with the co-design, and then finally they do the prototype. So that's why here we can see like SDL, is more on very structured way. They are using only one language. It's not confusing. And then, but then, of course, after you finish the SDL, the spec design language, of course, then you need to go into the same process again. But you have a good overview, and then on how you're going to connect the thing. But the heterogeneous, you just go immediately on this hardware. Why there are different process like this? Because it's all about time, right? It's all about time. They want to be fast in the market, so that's why the term rapid remains there, right? So hetero, then they start with this both hardware and also software, and then go determine whatever the module that you need to have. Then you go into the communication, the COM part, right? So the COM part is how you connect all those modules. So you have the IP for video, you have video, right? You have the audio, and then you have the Wi-Fi. Then how you want to connect this module. Right? So if you want to use bus, right? So what bus that you want to use, right? So where's the processor and whatsoever, right? So communication module. Okay. Alright, so what else in this case? Co-design conditions and homogeneous. Okay, so heterogeneous model allows use specific language for hardware software part. Co-design start with a virtual prototype when the hardware software partitioning is already done. In this case, the prototype when the hardware software partitioning is already done, so you already determine what software you need to use, hardware you need to use. And in this case, co-design is a simple mapping of the software and hardware parts on dedicated processor. So the key issues with such scheme are validation and interfacing. Right, so the use multi-language spec requires new validation techniques able to handle multi-paradigm model. Okay, why is this happening? Because for an example, right, if you use the spec design language, then you already look into thoroughly into the connections, and then whether it can be done or not, right? But here you just determine the blocks, then you connect it, so the validation will comes a bit complex, because you need to validate later whether your design gonna work or not, right? Because you are developing simultaneously the hardware and also software, and then at the same time you have to test whether the communication between modules gonna work or not. Validate, right? Whether it's gonna work as it functions or not. Right. So the use of multi-language spec requires new validation techniques. Okay? Instead of simulation, we need co-simulation. Instead of verification, we need the co-verification. Okay, means that instead of you try to simulate the whole thing when it's completed, So every time you have a small connection, then you start to validate it. Example, try to use communication between video. This is just example, right? Video and audio module, Wi-Fi, and let's say there's a processor, right? Maybe they don't need to communicate each other, so Wi-Fi need to communicate with processor, and then you connect audio need to be connected and communicate with the processor. Try to validate each of all modules communication, whether it's going to be working functionally as you want or not. All right. Okay. This additionally, multi-language spec brings up the issues of interfacing subsystem, which are described in different language. This interface need to be defined. Okay. The challenge in multi-level modeling and code simulation, right? So when heterogeneous, right? So we are talking heterogeneous because when you say heterogeneous, we are talking about multi-language in the modeling. It means that since the beginning you are already using the multi-language. For the homogeneous, in the beginning you are just using one language, which is the spec description language. But for heterogeneous, when you started it by using this multi-level language, so it create a lot of barriers, right? Because of course software is using C, right? C looks very different from Verilog, but I mean, just talking about C and Verilog. What about if there are some designer they're using MATLAB, right? So if you look here, MATLAB, right? So some using C++, because just imagine that they are developing the algorithm, right? For example, they design, let's say they design a image processing, right? So image processing, so they design it using MATLAB. So they take image, then they use the MATLAB programming, then they got the output. Now from the MATLAB coding, they want to change it into SoC design. Right, so of course it's gonna be complex, right? Then you have to interface it with C, then you have to interface with Verilog. So this create, some challenges when they want to have this hetero modeling. Right, so when a large system has to be designed and separated by groups, they may have different cultures and expertise with different modeling styles. So the spec of such large design may lead each group to use a different language which is more suitable for spec. Right, so in the future, right, so you need to have interface to have a different, language for this modeling, right? This is the link for SDL. All right, so this is a two-word system, multi-level modeling code system. Okay, so for example, you use SDL, then some part you use C, VHDL, and then you use state chart, right? So it's almost similar with SDL. Then some of it use MATLAB. So you can have various language in the beginning, but then you need to. This is the platform that we're talking about. The platform that combine the whole thing and then come out with the system design, right? So to connect and to interface the whole thing and to combine it into one working design, it's not an easy step to do lah. Right, so for an example, right, so this one is the example that we are talking about right here. I mean, this is a straightforward example. Right, so this is already, they say want to use video, 8K video whatsoever. But let's say, there's uh, a company that come to us, and then they say like, okay, here's the spec that we want, so they say like, okay, we run a MATLAB simulation for image processing, right? So we got this result and this is the process, right? So using MATLAB, so we want it the system to be able to process this, and then we also need it to be able to convert, the image into, let's say, high quality image, for example, like 4K image, and then we need to have something, all the specs that they want. So here's already MATLAB, right? But then in the rest of the spec, you might need to use C, and you might need to use Verilog, right, for the hardware part. So combining all these things together, you want to combine it into one SoC. This is the challenging part. But this is what happening nowadays, right? So if you look into, for an example, right, Intel M1 processor. So they have the idea. Okay, they say like, okay, just imagine. Okay, they say how the design process works. Okay, they say like, okay, instead of using Intel processor, where we are wasting a lot of power because a lot of components that being not being fully utilized. So let's say, this is the Intel chip, so maybe you just utilize on this small part, right? So let's say 45%, just focusing on this part because it is a general processor, right? So it's a general processor. So I mean, it's meant to be working with a lot of applications. But right now, Apple want to focus on image, right? So Apple, right, they want to focus in image. So what are the design or the block, the IP that you need in image? So that's why Intel decided to come out with their own processor. So they decide. So they only put all those blocks that they're really going to use in the processor. Right? You see how it works. So they design it. Of course, there's an image. Using C, using Verilog, and then sometimes maybe using MATLAB whatsoever. So they design, they combine it, then finally they have their own SoC, right? The M1 processor. It's a very powerful processor. It's shocking the market. At first, when it was released, a lot of people was skeptic. They say like, this is lousy things. How can Apple is not a processor company, right? It's a mobile device company. Apple Watch, iPad, iPhone, and whatsoever. How come they want to come out with their own processor? But then when they come out with their own processor, M1, people were shocked. Like how did this company come out with very efficient technology and almost beating other processor, right? So M1 processor. So they are using the heterogeneous spec and then come up with system design and then prototype, virtual prototype, right? So in addition to hardware software, system may include other kinds of subsystem, right? So because it is an SoC, right? So means the modules that you cannot achieve by using the IPs. Maybe you need to have the mechanical analog devices, right? So can you guys think of one example, mechanical or analog devices that we can embed into SoC? Any idea, guys? Apart from digital block, any guess, guys?
Graphic card.
Graphic card is still digital, Chuck, because it is process the digital data, right? And then output is digital, the image. In your phone example, right? What is analog in your phone?
Speaker.
Okay, speaker is analog, but right now there's no there's no necessity to embed speaker in SoC. Any other things that you might think of? Do you guys play games using your phone?
Yes.
Okay, do you guys play like racing game whatsoever?
Yes also.
So you are able to control the car just by moving your phone towards some direction. Is it correct or not?
Yes, is correct.
How they do that? Any idea? Q?
Virtual button.
No, you don't have to press the button. You just move the phone, right? And then you can also move the car in the game. It's like you're driving your real car. So when you tilt your phone to the left, the car gonna turn to the left. When you tilt your phone to the right, the car gonna get to the right. Have you played that kind of game before?
Is it sensor?
Yeah, it's sensor. Do you know
Gyro.
what? You know any idea what sensor they use?
Gyro.
Gyro, yeah, gyro or accelerometer lah. Right, so those are, they call it MEMS, right? There's a micro. I think you learn about it. Did you learn about MEMS?
Yes.
Yeah.
There's got a lot of different kind of maps.
Yeah. So MEMS is a combination of mechanical and also electronics. So these MEMS, I mean, you can embed it in the SoC. Right, so that's why they have the mechanical analog device. So example, that gyro, the accelerometer, you can embed it in the processor, or you can embed sensor, temperature sensor, just to check, the temperature of the, your SoC. Right, so there are a lot of things. So hardware software is the main, but you can also have this subsystem, and then you come out with the prototype. Okay, target architecture. The target architecture used, to implement a design can be classified in one of the following cases: monoprocessor, main processor acting as top controller, a set of hardware components, ASICs, FPGAs, a distributed architecture composed of set of processors running in parallel. So yeah, this one is like what I've told you guys now. So it's really depend on the usage, right? Usage needed. Have you guys heard of TensorFlow? You know TensorFlow, guys?
No, Doctor.
Who know? Any of you know Tensor?
No.
Okay, Tensor. Tensor. If you Google TensorFlow, it is an application for machine learning. It's developed by Google. It's for machine learning, and then they come out with tensor processor. So this tensor processor, so there is really optimizing on the machine learning process lah. So it's very fast compared to other processor, and it's very efficient. So why I'm telling you guys this? So later you guys gonna know, which processor that or what kind of architecture that suit your application. So let's say if you guys are asked to design, very high level. Let's say for example, design a video processing, right? So video processing, you can do it the process in parallel. Okay, why? Okay, video. How do you process a video? Video is just a set of many images, right? So there are many images, many frame, and then you just layer it out, and then it create a video, right? So that's why if you guys record a very high resolution video, you're gonna consume a huge amount of storage because the pixel is very high, and then you are having, and then if it's a detail, slow-mo video, there gonna be a lot of frames, right? When a lot of frames, a lot of data, and of course consuming, huge amount of storage. Okay, so for video processing, you have to process each frame, right? So if you have only one processor, let's say one processor, right? So you have to process one frame at a time, which is going to consume you, of course, a lot of time. So instead of having one processor, okay, why not having a multi-processor, right? But multi-processor, that the processor that you use is a very specific for image processing. So instead of processing one image at a time, you can process multiple image at one time. You got it? Alright, so that's why I mean distributed architecture, composed set of processor running in parallel. Of course, the cost gonna be high. Right, so that's the idea of having multi-core lah in the current processor. That's why like for example, Intel, right? So by using the Moore's law say that the number of the what they call it what Moore's law, the number of transistor will be double every year, right? If still
Yes.
remember that,
Yeah,
still
yeah.
remember, right? Okay, so the number of transistor will be double every year, but right now it's not doubling every year. It's doubling every 1 year and a half. Okay, when the number of transistor can be inserted in the same space, larger and larger, you know, as the times, pass. So what happened is that they can have a more design in it. So that's why they are thinking, previously Intel is thinking, or any other processor company, they have only one processor. So how they want to increase the performance, they use pipelining, Scala, whatever you learn in the computer architecture, and then they start to increase the frequency, right? The clock frequency. If you look into the previous hardware Intel processor design, it goes up until 4.2 gigahertz, right? The frequency. What happened is that when the frequency is high, a lot of processing can be done. But what happened is generate a lot of hits. Right, and then they say that okay, we almost reached the bottleneck. We cannot increase the frequency anymore, else it's gonna be too hot. It's gonna blow the processor out, right? So what happened is that they say okay, now the Moore's law is keep on improving, right? Of course, they can have more transistor in one design. So instead of having one processor or one core, why not we change the design into multi-core. Right, so instead of having one processor inside the chip, so we have a multiple processor. And then so that's why you see right now the frequency is becomes low again, around 2 point something, right? Gigahertz. But the performance is better. Why? Because they have multiple processor. But this is of course GPU lah. And no, sorry, GPU, general processor, Intel. Okay, several configuration of processor, monoprocessor, multiprocessor, and several communication models, shared memory, message passing may be used. Right, so I think I don't want to go detail in this because this is on the architecture itself, right? So if you're using multiprocessor, you need to have a place where you store data, right? So you need to have, main memory, right? Main memory, and then you need to have cache, where you're going to put the cache, right? So how you're going to, increase the performance, all those details, right? So if you have, multi-processor, of course, the design gonna be complex, right? The challenge, but the result gonna be far better than mono processor, right? The classification is independent of the implementation technology. So both architectures may be implemented using single chip, multi-chip, or multi-board, or even multi machines, right? So yeah, I mean this is I think far design, single chip, multi chip, right? But we're not going depth into this one. Okay, target architecture. What else? Okay, this is the architectural model example, target architecture that being designed to cater this heterogeneous modeling, right? You can see here, I think this is not that important. It's just FYI. You see how they design the things. Right, so this is a mono processor, right? So you just have one processor that communicating with all the modules, and then here you have multiple processor, and then multiple processor can talk each other, but you need to have a bus, and then when you have a bus, you need to have the communication protocols that can let you talk with both of the processor. All right, so these are the current research issues on co-design, right? uh, SIP. So in this case, the designer starts with application, builds a specific programmable processor, and translate the application into software code executable by the specific processor. Right. So okay, I think this is the standard way of using it, designing it, but it's not really using SoC, or maybe they already using a specific SoC. So what they do is that in this case they just design the application, and then they build a specific programmable sub processor and translate application into software and code executable by the specific processor. So they design the application and then they convert the application into programmable processor. You can do this, for example, by using Verilog, right? So you can have algorithm in C, and then there's a, for example, Xilinx, right? Xilinx have a module where you can convert C programming into hardware. So you get the processor, programmable processor, and then from there it translates into application into software code. Right. So when you have, okay, example, right? So let's say they design the algorithm in C. So they say they design algorithm for washing machine, like example. So when the water comes in, whatever happen, right? So they run it in the software. So example like Vivado. So Vivado is a software, Xilinx software. So they convert it into Verilog, right? So Verilog. So you got the hardware, right? So when you got the hardware, then you need to produce another C language to control your hardware. C which being insert in your hardware, right? So this is application specific integrated processor. And then second issue is that hardware software synchronous system co-design. So in this case, the target architecture of co-design is a software processor acting as a master controller. Alright, okay, later. I think it's 47. Wait, okay, let me conclude. Let me conclude this subject. Uh, this one is just FYI lah, so you don't worry about it. So these are the thing, the current challenges. But okay, let's talk about, the real. Okay, this is the task that I'm gonna give you guys. Right, later I'm gonna let you know. Okay, but guys, apart from what we have discussed today, you can look into the SoC design. So these are all the top SoC manufacturer, right? So is this really process that you need to go through in the real process? Is depend, right? So for an example, right? Have you guys heard of ARM architecture, ARM? Have you heard of it, guys? Are you guys still there?
Yes, sir.
Still, sorry, I'm just spending 2 hours with you guys, but I'm really having fun. I like this subject. Okay, guys. Okay, Q. Have you heard of ARM before? Q.
Yes.
Okay, ARM. Okay, ARM. Okay, what are the product of ARM?
So far, chipset.
Yeah. So uh, the one of the main reason, why the revolution in SoC happened in the world is because of ARM. They don't have their own, fabrication facilities. What they sell is that they sell their design, right? So they sell their design, so SoC design, right? So and then of course the SoC design will be working with ARM processor. So ARM, they have their own processor, and which able to communicate and work with many other modules that produced by ARM itself. You got it? All right. Uh, Okay, what I mean is that, okay, okay, all right, okay, this is ARM processor, right? And then this is the IP. So when they provide ARM processor, right now they also have, you know, the ARM software, right? So ARM software that can work with the ARM processor. So for example, like, you know, I've worked with the FPGA and then using the ARM processor, and then they give us the software development tools, right, where you can then load your software in the ARM processor and you can execute it. So it's a complete working processor, right? So this is the modern SoC design, right? So when we talk about okay, what is the modern SoC design? So nowadays, if you want to design SoC, how it's gonna be? So normally it's just plug and play, right? So of course, the process is the same. You have to determine the spec whatsoever, right? Then you just, you know, if your company have all those IPs, right? They bought the IPs, so you have the ARM processor, and then you have a lot of modules where you can interface with the uh, and even some of the software already provided, right? So you just need to, you can check whether it's compatible with the module or not. If it's compatible, like Windows, if Windows can, for example, if you buy a Logitech mouse or any kind of mouse, right? So they already have a standard driver. You just connect the mouse without needing to install any driver. The mouse can work because why? Windows already support the driver for mouse, right? For example, any other module, right? So they already have the driver in Windows, right? So same goes with ARM. So if ARM already provided the driver for the modules, so you just connect the modules, right? Then you can simulate it, then you can prototype it. All right, but for prototyping, it's a bit complex, right? Nowadays, the prototyping will be done on the FPGA, right? So that's why you see in you know, a lot of FPGA right now, they have the ARM IP. You can load the ARM processor design on the FPGA, you know, be it Xilinx or Intel FPGA. Then you can prototype. You can try to run and check whether the design works or not, right? So basically that is the when we talk about the modern lah. But what you guys need to focus in this class is the flow, right? So the homogeneous and heterogeneous. You need to know when you can use heterogeneous and when you can use the homogeneous, and what are the things involved in homogeneous and heterogeneous, and what are the difference lah. All right. So any question, guys, before I give you guys task for next week?
No question, Doctor.
Okay. Shah, Omar, Ip.
No question, Doctor.
All right, Shah. Ip, got any question?
No.
All right, Ip. Okay, guys. So I've given you guys, this is the top 10 SoC manufacturers. All right. So the task for next week is that choose any of the company. So what I want you guys to do is that I want you guys to go and check the company website and check their SoC. So choose one high-end SoC and one low-end SoC. So you next week when we start our lecture, before we go into the next week syllabus, so I'm giving you guys 10 minutes each to present, you know, what are the high end SoC that you choose, and then what are the spec in it, and then present one low end, so one high end, one low end, present the spec and compare the spec, right? And then finally on both high end and low end, you try to guess, right? So what are the, you know, the modeling flow that you guys can use, you know, to design SoC using those SoCs lah. Okay, clear or not? Or you want me to give it in writing? Guys, is it okay? Alright, clear. Cha Q. Yeah?
Clear, Doctor.
Okay. Alright, so at least you guys can exercise your understanding. So I think that's all for today, guys. Thank you so much. I really enjoy the time with you guys. So hopefully you guys enjoy the time with me too. So take it easy, take it easy. Don't worry so much about the assessment whatsoever. So my goal here is that it's only for four of you guys. So I really want to give you guys this knowledge to boost your value, right? So by having this knowledge, I'm really hoping you guys can improve your knowledge and improve your value in the market. So after this, the current trend right now, there's a shortage in the chip supply. I'm not sure you guys are aware or not. So there's a shortage in the chip supply in the market because of the COVID-19. So what happened? That's why you see MITI they listed the E&E industry in one of the essential business because to cater this issue, you cannot stop them from going to the company because we have to overcome the shortage of chip in the market. So as the shortage in the market becomes crucial, and then the company is increasing their manpower to overcome this issue. So a lot of hiring happening right now, a lot of expanding happening. So there's a lot of opportunity for you guys. Even Q, I think there's a company in Sarawak, right? I think Micron, right? Micron they have in Sarawak.
Not sure, Doctor.
Yeah, I mean, there are few IC company in Sarawak lah. So even in Selangor, yeah, maybe Omar wants to go back, or you can find some opportunity here. So there are a lot of companies are expanding and having this advanced knowledge will help you guys. But I think the most important thing is how you exercise the knowledge. So that's why I'm giving you some tasks. Just for you guys to exercise your knowledge. To increase your knowledge. What is the SoC? What are the company that produce the SoC? Example of the real SoC, right? So that you can get the grip of the real thing. It's not just theory you learn, but you know what's happening in the market, right? Okay, I think that's all for today. Thank you so much, guys. If you have anything you need to know or you want to know urgent, you can just WhatsApp me.
Okay, thank you, Doctor.
Okay, Doctor. Thank you,
Alright.
Doctor.
All right, thank you guys. So see you guys next week.